If there's friction, you do that. Okay? But you can see, now let's think about the velocities here. That's my cheerleader tryout. I tried out for cheerleader in college because they had free donuts. What if there's friction? Was that a herky? That was supposed to be a herky. I don't know. Okay. Okay, so now we're going to do the same problem, except we're going to think about it moves, right? Oh, I thought I did the math. Hold on. I do have the math. Hold on. I think I'm missing a page. I can do it off the top of my head, but I think I'm missing a page. Okay, so now let's think about the person moves at some speed v. How fast does the sled move back, right? So if I'm going to move v, I want to get my subscripts right, p, well, it must be that this thing's moving back v sled, right? So let's do the numbers on that, okay? Okay, so 1, it's an isolated system. And what's that going to tell us this time? Before I moved, what was the velocity of the center of mass? 0. So as I move forward and the sled moves backwards, it still has to be 0. As I walk, the velocity of the center of mass never changes. Okay? Somebody could attempt to hold their head right on the center of mass, and it wouldn't move. But here's what's tricky about this problem. If you went and just tried to do it real quick as a collision, you get it wrong. And the reason is velocities depend on frame of reference. So in these problems, which I didn't put one in the homework, you got to think about what you're being told. Okay? If I say I walked on this mass, this sled, at like a half meter a second, what do I mean? Do I mean relative to the sled or relative to the ground? Well, it's going to matter. Okay? So let's think about that. Let's see. Yeah, okay. So the answer is you walk in the sled frame. The person walks in the sled frame. So really, when we say VP, probably what the problem means is VP really equals VPS. Remember with our reference frames. So let's say what they are. S is the sled frame. And G is the ground frame. So this is a good review for the final, right? So let's remember how this works. So the speed that my pedometer says is the velocity of the person in the sled frame. Okay? And then what do we ask for? We ask for VS. Well, the person writing the problem and judging and grading your homework is not on the sled, right? They're on the ground. So you're probably asking for VS equals the velocity of the sled in the ground frame. So what can screw these problems up is you're given information in different frames, and you got to translate them or think about what that means. All right? It's kind of weird. So we got to relate them. So let's remember what our relationship is. In this case, we want to do the person in the ground frame. This is what we want. This is probably what they asked for. Well, they asked for either one of those, right? Let's do the person in the ground frame equals the velocity of the person in the sled plus the velocity of the sled in the ground frame. Right? So that would be what we did in the first few weeks on relative motion. If we have P and what P and G, it's P and S, S and G. Right? You kind of break it up like that. Right? It's really dark. Okay, so now it looks like we made it worse, right? Because now we need more information. We can't really solve it now, but we can. We just got to work on it. Okay. So we know that V center mass equals 0. I can write that part. Okay, but now let's write an expression for the center of mass, or for V center of mass. Let's see. Okay. Well, just like the position of the center of mass, it's 1 over m total. 1 over mass of the person plus mass of the sled. Right? That's m total. And just like position, you just take each one's value times its mass. So we take the person's mass, m person, times their velocity, but we want it in the ground frame. Right? So we say, okay, the mass of the person, do everything in the ground frame. V, velocity of the person in the sled frame, plus the velocity of the sled in the ground frame. Okay? So that's just replacing VP. Right? Oh, wait, yeah. PS plus SG. PS plus SG is VPG. Yeah, person in the ground frame. And then, so this is person in ground frame. Right? Plus the mass of the sled, and it's what they gave you. It's what we're finding, VS. Right? It's the velocity of the sled in the ground frame. So the only one we had to really translate was the person. Okay? And that equals 0. That's really it. Let's see. So if you try to do that in your head, you usually screw it up. I always screw it up. If you try to say, well, now let me think about it here. I'm really moving this, but I got to subtract that, so I got to put it in. You'll end up putting in a negative sign, and it usually goes wrong. It's better to just say, I'm going to conserve the center of mass in the ground frame. Or I'm going to make it 0 in the ground frame, therefore this is in the ground frame, and that's in the ground frame. And that'll tend to get it right. Okay? Now, are we good at algebra? This has to be equal to 0, so that's irrelevant, right? Multiply both sides by MP plus MS, and that goes away. Therefore, this needs to be equal to that. So what do we get? Well, let's see. If we're going to bring, what are we solving for? VSG. We're solving for this one. Oh, and it shows up twice. Look at that. So we have just 3 terms equal to 0. So we go ahead and take this one over there. And we get VS, the sled in the ground frame we're looking for, times MP plus MS. All right. And what do we put on the other side? MP and then V of the person in the sled. All right. So we're just trying to get there. And what do we get? We get the velocity of the sled in the ground frame. What we were asked for is the negative times the mass of the person over the mass of the sled plus the total mass. The mass of the sled plus the mass of the person times the velocity of the person in the sled frame, which was the one we were given. Right? So there it is. It looks exactly the same, except it's backwards. Right? It looks just like this. Oh, wow, could we have taken a derivative of this? I didn't even think of that. No. Let's see. No, we couldn't have. Yeah. It wouldn't have worked. Yeah. But it looks very similar. So the pullback is just the ratio of the my mass, the person's mass, to the sum over the displacement. And here, it's just the ratio of my mass to the sum times the velocity of the person walking. And there's a negative sign, of course, because it goes backwards. Right? If you don't have that negative sign there, it doesn't make sense. Okay? All right? So you see, we did physics with just center of mass. The only physics in it is that the center of mass didn't move. And the rest is just like geometry. That's what's supposed to be cool about this. Okay. I think the homework has one of these, but not one of these, is what I recall. The suggested problems, I'm not sure. I can't remember. And if you're wondering, why do we use relative frames here, but we don't use relative frames here? And the answer is we did use relative frames here. It's right here. We just didn't make a big deal about it. Right? We said that's really where it is. It's L minus S. And then we translated it from one frame to another. It's just usually relative frame problems. You always think about it in terms of velocities. For some reason, it's just intuitive with positions. But velocities, we always have to write out this Galilean transformation thing. Okay? Okay. So let me look at questions, and then we'll have our last topic for 2D for this stuff is 2D motion. So here's a good question. Is the velocity of the center mass 0 in any reference frame, or do you have to choose carefully? The answer is yes, you choose carefully. Usually you choose the reference frame of what the question is asking you for. That way you'll solve something that's actually what they're asking for. It won't be 0 in every frame because reference frames can be moving with respect to each other. But if you're just talking about moving the origin, then it won't matter. Like you could have 2 reference frames with 2 different origins, but they're not moving. Then it'll always be 0 in all those. But yeah, you would want to choose carefully. But this won't turn into a big relativity exercise. Okay, we're mostly just doing that, not so much of that. So that wouldn't be the point of making it difficult.